Hello everyone, my name is Rodrigo and today we're going to be solving Advent of Code Day 4 and this should be the third day where I start the stream without any sound issues. So if you can hear me, just say something quickly to double check that everything is set up correctly. As I said, we're solving Advent of Code Day 4. I have solved the problem beforehand, so you're not... Bad code was very funny in the chat. Yes, something quickly, quite literally. So this is not the first time I'm solving the problem. I've solved it already. What I'll show is my thought process, or the thought process I went through when I was solving it for the first time, and then a couple of thoughts I had. But of course, I am prepared. So you're not. This is not the instantaneous reaction to the problem. So let's take a look at the problem. I won't be reading the problem statement. I'll just give you the gist of it. You have a grid that looks like the one shown on the screen. It's a grid filled with dots and the @ sign. And the @ sign represents rolls of paper, because why wouldn't they? And what you need to do is you need to figure out, for part 1, you need to figure out how many rolls of paper have fewer than 4 rolls of paper in the 8 adjacent positions. For example, the @ sign that I'm highlighting, let's see if I can zoom in even further. The @ sign that I have highlighted has the @ sign at the top and the @ sign immediately on the bottom and to the left. It only has these two neighbors, so this @ sign would be counted for our problem. But for example, the @ sign I'm highlighting now close to the center is completely surrounded by @ signs, so you don't want to count that one. So you want to count the @ signs that essentially can breathe, that have some room around it. And because this problem involves a grid, I always go back to the same way of handling grids. Let's do a quick diagram. So whenever I have a grid, I do this. 1, 2, 3. Let me think for a second. How many of these do I need? Is this enough? Yeah, and now this goes here. Alright, so this is a part of a grid. And let's say that the central cell has coordinates x, y. And in computers, x usually increases from left to right, and y usually increases from top to bottom. There's a reason for this. I don't remember what the reason was, but you usually go from top to bottom. So given these x's, and given that the center location has coordinates x, y, you can easily get the coordinates of the surrounding or the neighboring cells. So if it's immediately above, you just subtract 1 from y, for example. Or if it's to the right, you add 1 to x. And what you'll see is that every single position that's around you has a small offset in 1 or 2 of these coordinates. For example, this corner over here would be x plus 1, y plus 1. So you can quickly, given a cell, you can quickly get the neighbors by playing with these offsets. And that's what I'll do. So regarding y going up as you go down, I believe it's because of the pixel by pixel display on old CRT, where each pixel is drawn individually starting top left. I don't know. I have no idea if that's true or not. I don't even know what CRT is. What's CRT? Something something terminal? I don't know. Alright, let's go and solve this. Let's create a directory for day 4. Cathode ray tube monitors. Yeah, I have no idea what that is. All right. So with that out of the way, let's write some code. And now create a file for our solution. All right, so I was talking about the neighbors. So the first thing I'll do is I'll create a tuple with all of the offsets so that whenever I have a couple of coordinates, I can easily access the neighbors. And then it's going to be 0, -1. And I'm 1, 2, 3, 4, 5, 6, 7. But this is repeated, so I'm doing something wrong. I increased this one. I fixed the one. Oh, right. I fixed the one and I decreased this one. And now I fixed the -1 and I increased this. Okay, so now I have the 1, 2, 3, 4, 5, 6, 7, 8 neighbors. So given a position, I can use these offsets to easily get all the other neighbors. Now I'll create my function to parse my input, even a file path. I'll open my file, and this is how I thought of solving it when I first read the problem. So I'll just read the file to create my grid. So my grid is a list of all of the lines. So f is an iterable. By turning it into a list, I get a list with all of the lines from f, which makes up my grid. Now actually I'm thinking I want to get rid of the new lines, so I need to read the contents in and then use split lines. And now I return the grid. And now to solve part 1, given a grid, what I want to do is I want to go through every single valid coordinate I see someone in the chat. What does def do? I'm not sure if you're talking about this def. It's apologies, someone was having fun with the motorcycle outside. If you're talking about this def, this is to define a function. So I'm defining a reusable piece of code so that I can easily parse my input. Now, I have a grid and I need to go through it. I need to look at each @sign and count how many @signs you have in the neighboring positions. That's essentially what I have to do. So once I accept my grid as an argument here, I'll check the height of the grid. That's going to be given by the length of the outer list, and then the width of the grid is the length of any of the rows. And now what I'll do is I'll go through the grid. First, I can use enumerate to access all of the rows, and then I can use enumerate again to access all of the cells. Sorry, for cell in enumerate row. By using enumerate, I get access to the coordinates, but also the cell that I care about. And now, if the cell is not an @sign, I can just skip it. If it is an @sign, I'll look at all of the neighboring offsets and I'll check if the neighbor is an @sign or not. So the neighbors is a counter that starts at 0. And now for the x and dy are these small offsets, the small changes in the x and the y that allow me to access the surrounding positions. What did I call this? Neighbor offsets. The neighbor x and the neighbor y are given by taking the original coordinates and summing the offsets. So x plus dx, y plus dy. And now I need to check if these are valid coordinates or if they fall outside of the grid. So if nx is a valid coordinate and ny is a valid coordinate, then neighbors is incremented by 1 if this neighboring position is an @ sign. Or maybe, for the sake of simplicity, alright, so if it is a valid position and it's an @ sign, I'll increment the counter, the neighbor's counter, and when I'm done, if I only have at most 3 neighbors, then the final count is incremented by 1. Hey there. And when we're done, we return the final count. Now this should be it, unless I'm missing something. But we're going to figure out if I'm missing something really soon. Feel free to ask any questions you might have about the code. I'm going to grab my puzzle input and then we'll run this. So if you have any questions, write them in the chat. Alright, so I download the input. My answer should be 1464. Let's see what I get if I run the code. So let's run solution.py. Oh, I get nothing because I defined the functions, but I'm not calling them. So if I run this piece of code, this script directly, so if the name is main, I'll want to grab my grid, and then I'll want to print the result of part 1. Now we run, and we get an error because my neighbor offsets was missing an S. Let's run this again, and the answer is wrong. Okay. So I got 1140 and I should have gotten 1464. So I'm missing a couple of cells. So what's the problem here? Alright, so the final count. First of all, let's make sure I'm counting the correct thing. So the answer says, so they want to know how many positions can be accessed. All right. Now, did I miss any of the neighbors? That's what I did this again. So 0, 0, 0, this stays put. This stays put, then this goes there. Alright, so the problem is with my offsets. I don't know how math works. So these, and then you go there, and then you go here and here. Let's see if I got them right. 1, 2, 3, 4, 5, 6, 7, 8. Why no traversal? This is -1. What do you mean why no traversal? We are going through the, so we go through the grid. We are going through the grid. We are traversing the grid. And for each valid cell, for each cell that is not the dot, so for each @ sign, we look at the neighbors. Is this what you meant? Yeah, so we are, if this is what you meant, then we are doing traversal. Okay, I need a second because I'm clearly getting the offsets right, so I'll redo them. So let's start at the top left. At the top left, it's -1, -1. Then we go above. Then we go to the top right, and then we go to the right, and then we go to the bottom right, and then we go under, and then bottom left, and then straight to the left, which should be -1, 0. And then we've gone around the central cell. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So my issue was with the neighbor offsets. For some reason I list them all. I didn't list them all correctly. Well, I'm saying this assuming that's gonna work now. Okay, it is. It's working now. I was just silly and couldn't list the offsets properly, which is maybe the least interesting bug I could have had. 1464 is our solution. I'll give you a second to ask any questions you might have about the code. Well, now the follow-up, this was part 1. The follow-up, let me zoom out a bit. The follow-up asks something along the same lines, but slightly more involved. So first, we were counting how many @signs were accessible. This being accessible is for @signs that have a small number of neighbors. So first we were just counting how many of them were accessible. Now you're supposed to do an iterative process where all of the @signs that are accessible, you remove them. And then you check again which ones of the ones that are left are accessible, and you remove them. And then you check and you keep doing that until no more @signs can be removed. And when you get to that point, you just return the number of @signs that you removed in total. And as soon as I read this, I thought, well, I already have a piece of code that goes through the grid and figures out which @signs are accessible. So instead of, so what I can do is I can take that piece of code, instead of counting the accessible @signs, I can keep track of their positions, and when I'm done, I remove them and I call this function again. So I just apply the function from part 1 repeatedly. And this is fairly, quote unquote, straightforward to implement, or at least the idea is simple. So that's what I did. I can go here, I can change part 1. Should I change part 1? No, actually what I did when I was solving the problem for the first time was I copied the whole code. I copied it. And I pasted the code. I call this part 2. Now what do I want to do? I want to run part 1 a bunch of times. So I created a loop around it. Now, the count should be outside the loop, apologies. So I'm going through the grid and I'm changing the final count here. This is not what I want to do. What I want is to keep track of the neighbors or the cells that will be removed. So to be removed starts off as an empty list, and instead of accounting for this cell, I mark it to be removed. So to be removed dot append the cell that needs to be removed. And once I'm done going through the grid, so outside of the for loops, but inside the while, I go through the cells that need to be removed. And I remove them. I mark them as being dots. So they were @signs, now they're dots. And then I just repeat the whole process. And eventually I get the final count. Now the final count needs to be updated to reflect how many cells were removed. So the length of to be removed. And this is part 2. And I added just 1, 2, 3, 4 lines of, okay, 5 lines of code. But part 1 was essentially copied and pasted here. Now, will this run? No, it will not. Who can tell me? I mean, it's not easy to get it right, especially since you can't look at the whole code and I'm the one writing it, but who can tell me why this will not work? And I'll give you a hint. The problem is in one of these 3 lines of code that I highlighted. What's the problem here? Nice, yes. So someone in the chat got it. I'm assigning to a string in here. My grid is a list of strings, which is how I parsed the input originally. No, X and Y are not reversed because when I'm accessing the grid, because my grid is a list of rows, Y comes first. So the problem really is the string assignment, and I can run this to prove it to you. We see type error, stir object does not support item assignment. To fix this, you go to where you were parsing your input and you just turn each line into a list. So you do list of line for, oops, that's not how I want the code to look like, for line in F, and you'll want to strip it of white space, and this should cut it. UV run solution, you get 1464 in the beginning. Now why is part 2 taking so because I forgot to break, of course. So I have a while loop in part 2 that goes through the grid repeatedly, but I need to stop at some point, right? Of course. And the point at which I stop is when no more add signs were removed. So once I go through the grid one time and I cannot remove a single add sign, there's no point in going on, because I know there's nothing else to be removed. So what I'll do here is, if there's nothing to be removed, then I just break. And now we run. And this time it should work. All right, and it does work. So the answer I get here is 8409. And if I compare it with what I had on the website, let's check, give me a second. 8409. All right, questions about the code? Let me know how you feel about this. I feel like this is a pretty reasonable solution. You could say it's kind of brute force because you're just going through the grid over and over again. But since it works so fast, I mean, there's no shame in using brute force. It's essentially instantaneous. So it's a pretty good one. Now let's do a quick pulse check. How does this work? Let me create a poll really quickly. Because now we can do one of two things. We can look at a more efficient solution, or we can create a visualization for this problem. And I'm creating a poll in the chat, so let's do this or visualization. So you can pick what we're going to do now. Let's see if I get any replies, otherwise I'll just flip a coin. Let's see, I can see the percentage of answers, but I'm not sure. I can see how many votes we got. So let me give you one more second to vote. All right, I think the visualization won. I know, strictly speaking, I'm still halfway through my visualization from day one. But since this one happens on a grid, this one is going to be easier to do, and I'm pretty confident we can do it in the next 30 minutes. All right, let's end the poll. The fate has been sealed. We'll work on a visualization. Let's create a new file called vis.py for the lack of a better name. Now I need to have an idea. I have no idea how big the input is, and that's actually going to be helpful. So there's 136 rows, and what's the length of each row? Count. Okay, 136 by 136, so we can comfortably make that 4 times larger. Alright, so what I'm thinking is we'll have a square grid. We'll have a square grid where each @ sign and each dot represents a cell in our visualization grid. And the @ signs will be filled in. So these two @ signs will be filled in, and the dots won't. And as we remove @ signs, we'll maybe color them or make them disappear from the grid. We'll figure out what looks cooler. And what I'm checking is how big this cell will be in terms of pixels, and I think I'll make this a 4x4. So 4 pixels for each cell in the grid. Alright. Let's start by asking UV to give us Pygame. So UV let's add Pygame as a dependency to our script. And let's make this run with Python 3.12 because actually just for the drawing I don't think this is going to be a problem, having 3.14. We'll import Pygame. We'll set the screen. So we'll grab the grid from our input file. So the grid is what we have in the solution. Where is it? This. So we have a grid, and now the cell size is 4 pixels, which means that the width of the whole grid is going to be cell size times the number of columns we have in the grid, which should be the length of any of the rows, and the height of the visualization is going to be given by cell size times the number of rows we have. And now we're going to need a couple of colors. So it's going to be white, black, and let's do just red for now. This should be enough. Now we create our Pygame screen. And now let's create a function that accepts the grid and draws it. So draw grid on a surface. So given a surface, which is, let's just do given a grid, draw it. So draw grid, what we do is we go through the grid by first iterating over the rows. And this trick of using Y row in enumerative grid and then for X cell in enumerative grid, this is very helpful. A very convenient way of going through the grid, getting the coordinates of a cell and also getting the cell contents. So before we draw the grid, we're going to set the background to, let's do white. And then if a position is an @ sign, then we draw a black square in that position. So for that we need to use pygame.draw.rect, which stands for rectangle. Now I need to check the documentation because I don't remember what are the arguments that this function needs. So rectangle takes the, where is it? It takes the surface, which is the screen. It takes the color, which is going to be black, and then it takes the rectangle that positions the rectangle I'm drawing. So we need to create a rectangle. And the rectangle in turn takes what? I'm not sure if it's first the coordinates and then the size. Yes, to create a rectangle, you give it the leftmost and topmost coordinates and then its width and its height. So left, top. Left is going to be X times cell size. Top is going to be Y times cell size. And then the width and the height of the rectangle itself is cell size. So we draw the grid. Draw a white grid with @signs in black. In the beginning, we set the grid to whatever we get from the file. We take the screen and we update it. And now we set the event loop so that the application doesn't freeze. So for each event in pygame.event.get, if the type of event is us trying to get out of the app, then we just quit. This should be enough. Let's see if we get a grid on the screen. We need to give it a second because Pygame is a bit slow to load the first time around. And there's nothing on the screen. Amazing. It didn't crash, but there's nothing on the screen, which is a bit of a shame. So what did I do wrong? Black and white are different colors. So that's a good start. We fill everything if cell equals. We draw the grid, we display this, we flip the screen. Screen in black. The left, the right. Let's print whenever I try to draw something. Oh, so I'm not going into the... because of the... Of course. The inner loop, I should be going through the row, not the grid again. So there was a mistake there. Let's run this again. And now we get the grid. Alright, much better. So this represents our grid. And now what I'm thinking is... for the whole process we're doing is we go through the grid, we paint in red all of the cells that we want to remove, and then we remove them from the grid, and we do this repeatedly. I think that might be cool. So now how do we do this? Because there's the most correct way would be to intertwine this animation with the Pygame event loop if we wanted this to be correct. But Pygame really is for games, not necessarily for this visualization. So maybe I can cheat a little bit. Okay, so let's try to do the following. Let me check the function display.update, which will allow me to update just a small portion of the screen. First off, it allows only a portion of the screen to be updated. Alright. So how do we do this? We're going to take the code from part 2, the whole thing. We're going to paste it in our visualization. And now we tweak it to modify the grid as we go. So every time we add something to be removed, we need to draw it in red. So draw this cell in red. So what we're going to do is we get the cell rectangle, which is the left, the right, sorry, the top. So the left and top positions of the rectangle and its width and height. We're going to draw it in red. So pygame.draw.rectangle on the screen in red, this position. And then we ask Pygame to update the display, but only this small portion, not the whole thing. Because if we update the screen, the whole screen every single time we change something in a rectangle, Pygame is going to get really slow. So we draw the cell in red, and when we're done, when we're removing the cells, what we want to do is to actually set them in white. So we need something like this, but in white. So draw this cell in white, which will essentially make it disappear. So we change the color to white and we update the screen there. And then we don't need to count them. I wonder if this is enough, or if I'm missing something. I'm the kind of person that would miss something here. Let's see what this looks like. Neighbor offsets is not defined, so we need to copy that as well into our visualization. Let's put it next to the other constants. Let's try this again. Name width is not defined because it's in all uppercase. Where is width? And height has the same problem. And now list index is out of range. Oh, come on, what am I doing? Oh, because width and height, all caps lock, sorry, were the dimensions in number of pixels. But this needs to fit the grid width and height. So the grid height is the length of the grid, and the grid width is the length of any row. So this is grid width and grid height. Where is it? It's running somewhere. Oh, but it started. Can you see it, or is it too small for you folks? Or can you see the process of the red dots appearing and then disappearing? Let me stop this now, because this is not interactive, because I'm not doing this the correct Pygame way. I cannot close the window. I have to stop this with Ctrl+C. But we can do something else, which is we can wait for the user to press S to start, otherwise it starts before it even goes on the screen and you cannot see it. So here we wait for the user to press S. And so if there's an event which is of the type key down, I think. Is this it? I don't know. Let's quickly check the documentation. Event. The event types. I need to zoom out, otherwise I can't navigate. Alright, key down, there's no underscore. So if the key down is, so if the type is key down and the event key is pygame.keys, then we start. So while we don't want to start, we run this, then we start. I think I have the, let's see if I got the, okay, so it's ready. Now I'm going to press S, and I get an, the casing was wrong there. We try again. So it's still, and now I press S to start, and we can see, well, I mean, the contrast isn't great, but we see the red filling in or showing up. And then it's going to disappear and clear up some space. And then just keep going. I wonder if it would look cooler if the red cells just disappeared all at the same time. But yeah, I think this is a pretty decent visualization. And it took us less than the 30 minutes we had. So I'm pretty happy with this. If you have any suggestions to make this better, I'm all ears. Otherwise, we will... I think we can call it a day. I mean, this looks good. Alright, I'm gonna push this to GitHub. I do need to stop it though. Yeah. I'm sorry, Angie, you didn't miss a lot. It was just me mistyping variable names. What can we do? We can stop this. For myself, I would make this slightly larger to make it easier to see. And if I were doing this to share, maybe in a blog post, what I would do is I would get Pygame to save the frames and then make a GIF or a GIF. I never know how to say it. Is it GIF? I would make a GIF out of the frames, or maybe a video file. Something like an MP4. As a nice challenge for you folks, if you're watching, is to take this code, which is currently, if you see the wheel spinning right in the middle of the screen, it's because, strictly speaking, the window is unresponsive. I cannot interact with it. I cannot close it, for example. Because I'm running all of this code without letting Pygame handle my user events, like the mouse moving, the user trying to click stuff. So it's a very interesting challenge to do something like this that also allows the user to interact with the application. For example, press space to stop or to pause. How would I do it? It's a very interesting challenge for you to try. All right. Unless anyone has any questions, we can call it a day, and we'll be back tomorrow at the same time, 5 p.m. UTC, to solve whatever problems Advent of Code throws our way tomorrow. Folks, thank you so much for watching. I'm going to upload this to GitHub. I'll paste the link in the chat before sending you away. Give me a second. So let's add day for visualization. Let's push. It's here. All right. The link is in the chat. Thank you so much, everyone. And I will see you tomorrow. Bye.